right? So we're doing applying the basic rule of integration that says if my integrand is in this form, ax to the n, then the integral would be ax to the n plus 1 all on n plus 1. In this case, we don't put the plus c because we're dealing with definite integration, right? So considering this expression right here, if I apply this rule, I'm going to get, I can use yellow, yeah. So we're just looking at this, right? All we're doing, integrating this by first term, 2x cubed. Okay, good. 2x cubed. If I use this rule, I'm going to get 2x n plus 1. N in this case is 3, right? 3 is the power. So it's 3 plus 1, which is 4, divided by 3 plus 1, which is 4, minus x. It's understood that this power here is 1, right? Because according to our laws of indices, anything raised to the power of 1 is itself. So by saying x, I mean x to the power of 1. So n plus 1 is 1 plus 1, which is 2. So that's x squared. And then it's divided by the n plus 1, which is also 2. 65, yes, that's correct. Don't forget to put your units, so you'll put units squared, since this is area. Minus 19, it's understood that this is x to the 0. So 0 plus 1 is 1. And then you divide by the 1. Remember, no plus c, because this is definite integration. Simplify this a bit, tidy it up. You can reduce this and all that. And you're going to get this right here. The 2 and the 4, it reduces to a half, and then you have your x to the 4. So I could have left this as x to the 4 on 2. But, just to make it a little neater, I put it as a half x to the 4. Same thing here. I could have left it as x squared on 2, but I rewrote it as minus a half x squared. Then this one, anything divided by 1 is itself. So instead of putting minus 19x on 1, I could just write it as minus 19x. Do you understand that, Micaiah?
Yes, miss.
What's the, yeah, that's the value. Okay, good. Let me just finish the question here now. Where's Josh? He didn't join that. Yeah, that is right. So yeah, this value, the value of this bracket here is 44. You have your minus sign. And then the value of this bracket here gives me minus 21. This minus and a minus is going to give me a plus. So what I end up with is 44 plus 21, which is going to give me 65. But since we're dealing with area, you can't just leave it like this. You would lose a mark. You need to put your units. Okay. Everybody good with this?
Yes, miss.
Okay. I'm clearing.
Oh no.
Okay.
How is it? The value in the brackets is 44. Take away negative 21. I got negative 18.97.
For your final value.
Yeah, well, for the solving the blue brackets, I inserted in calculator for the brackets and stuff. And it gave me negative 18.98.
Good.
You mind simplifying any brackets manually, please? Or
Yeah, that's what I'm doing. So 4 to the power of 4 is 256, right? So that's 256 by a half. So it's the same as 256 divided by 2. Minus 4 squared is 16. And then by a half, that's the same as saying 16 on 2. 19 by 4 was that? 76. Let me just make sure to see my mental math. Yes, 76. Look at me. So that's my first bracket. Minus 3 to the power of 4 is 81. So then that by a half is the same as saying 81 on 2. 3 squared is 9. That by a half is the same as saying 9 on 2. And then 19 by 3 was that 19 and 27, 57. You good with these values so far? Yes, no?
Yes.
Okay. So we wouldn't just leave it as 56 on 2 because that can be reduced to 181. Let me 181, 128. 128. 16 divided by 2 is 8, so that's minus 8. And then you have your minus 76. Let me just put regular math. Minus 81 on 2, you know, that can't be reduced. 9 on 2 can be reduced. So this is what you would put into your calculator. And you would get 21. Let me see if I could, you know, just do that manually. 81 minus 9, that would give me 72 on 2. And then minus 57. So this is 128 minus 8, that's 120. And then 120 minus 76 is 76 is going to give me 44. And then this is minus 72 divided by 2, that's 36. 36 minus 57 is going to give me minus 21. And yeah, 65. You understand that?
Yes.
Oh gosh, you sure?
Yes. Yes.
Sure.
Yeah.
Okay.
I think putting in the entire long equation on the calculator can sometimes give you problems. I don't know why. I put the brackets and everything and
You see,
stuff.
for this definite equation, where you might see like these weird looking numbers, I do not recommend putting it into the calculator. You know, that might cause problems. So we've got one bracket, we've got the next bracket, then subtract the two values. So yeah, try not to use the calculator. Like, try not to rely on the calculator too much for this. Simplify it as much as you could manually, like I did here. And then around here, you could use the calculator. But don't use the calculator for this part of it. Can I move on now?
Yes.
All right. Can I go through the third one? Or you still need time? Wait, anybody did the third one yet? I saw you can find the group. Okay, I'm going to the third one, right?
Yeah, miss. Go through.
All right. So I have a curve that's defined by y is equal to x minus 2 squared. And then this is plus 5. They told me that it's bounded by the line x is equal to 2 and x is equal to 1. So the bigger number is always the upper limit, lower number is, well, the smaller number is always the lower limit. So I didn't even have to draw a sketch for this one. You don't have to draw a sketch of any of them, really. Just know, you see area under a curve, you're going to apply this. Your f of x is this, the equation for the curve. B is always a bigger number, A is always a small number. So f of x in this case is x minus 2 all squared plus 5. The bigger number is 2, so B is 2. Small number is 1, so A is 1. There's no need for you to draw a sketch, but to do a sketch for these questions, right? I mean, if it helps, okay, do it. But there's no need. It's really not necessary. So A is equal to, like I said, B is always the bigger number, so that's 2. A is small number, 1. F of x is always the curve, so that's x minus 2 all squared plus 5. Then you put your dx. From here, just use the rules of definite integration to find the area. The first thing you need to do, just forgetting everything else for a bit. When I say everything else, I mean the limit. All you're doing right now, integrating this expression right here. That's the first thing you need to do. That's what we did when we were doing definite integration, right? So all we're focusing on right now is integrating this term. How do we do that? Just apply your rules. Just apply the rules. So there's a rule from before. I actually learned this a while ago. It wasn't that long, but anyway. That says ax plus b, if I'm required to integrate an expression in this form to the power of n, then the integral is going to be ax plus b to the n plus 1. So you're still doing your n plus 1, just like the basic rule of integration. This is where it's different too. The denominator is not just n plus 1, like before. When you see an expression in this term, when you see an expression in this form, the denominator isn't just n plus 1. You have to multiply this by whatever the value of a is. And we said that a is the coefficient of x. So whatever number comes before x, that's your a. We did this rule already, right? No plus c, because this is definite integration. So now apply my rules to integrate this right here. If I follow this, I'm going to get x minus 2 to the power of 3. Why? Because 2 plus 1 is 3, right? So it's my rule. 2 plus 1, 3. Divided by, I'm still doing the n plus 1, so 3, but multiplying it by a. A is the coefficient of x. Whatever number comes before x. In this case, a is 1. So 1. And then you just integrate the 5 using the rules that you know. It's going to give you 5x. You put your bracket, upper limit 2, lower limit 1. Can you substitute these values now and then tell me the value of the area?
Miss, you mean plug in the value of the upper limit and then subtract it from the lower limit?
Yeah, like we were doing before. So put the 2 into here. Wherever you see x, replace it with 2. Then do the same for the 1. Subtract the values, and then you get it.
Miss, the answer would be 1.
Would be what?
1 question mark?
1? No, it's not 1.
Sigh.
It's fine. Try again. Anybody else has an answer for me? Right, is it recording? Yes, yes, I am. Good. What's the question? I want you to find the value.
-1 question.
No, try again.
What?
I want you to find, John, I want you to find the value for the area. So substitute these values into the expression.
Oh, is the one at the top we were using? I was doing the one at the bottom that you just erased.
No. This says the integral. This is what you're substituting your value into, not the other one. The other one was the equation of the curve before we integrated. 16 on 3. Yeah, it is 16 on 3. Substituting my upper limit into this expression right here, whereby you see x, I replace it with 2. So this is going to become 2 minus 2 cubed over the 3 plus 5x will become 5 by 2. So that's my first bracket. Then I'm doing the same with my lower limit. Wherever I see x, I replace it with 1. So I'm going to get 1 minus 2 cubed on 3. And then this 5x will become 5 by 1. Simplifying. 2 minus 2 is 0, 0 cubed, 0, 0 and 3, 0. 5 by 2 is 10 minus 1 minus 2, that's minus 1 cubed, that's minus 1, so that's minus a third, plus 5. That's what we end up with in this bracket right here. And you do all of that. So you can plug this into a calculator, or you can do this manually. 10 minus this right here.
Well, I got that. Yeah.
Okay, good. It's going to give me 14 on 3. And then this would end up being 16 on 3. Don't forget to unit. Good. Everybody good with this?
Yeah, miss.
Yes, miss.
5.33 units, centimeters squared. Could you
Wait, what? Can you repeat what you said?
5.33 centimeters squared or units squared when you do 16 over 3, or you leave it any fractions?
Yes, in decimal.
Actually, it's based on the question asking. Sometimes they tell you they want the exact value, or they might say leave it in third form. But if they don't mention that, then it's okay to use the decimal. Just 3 seconds on figures.
Some of these values are so odd and weird, it's so recurrent, and it just goes on and on and on.
That's why, like during the exam, if you get a 16 on 3 or you get 5.3336, whatever, you're probably gonna think you're wrong because it's not a very nice number. That's why it's important for you to make sure you know what you're doing, make sure you check over, because sometimes these numbers can be a little weird and you might think that you're wrong, but that's not necessarily the case. Like
How
I
useful
said,
is the supplement? Is the
what?
How useful is the sheet at the front, the supplemental sheet? Does that help?
I mean, if you want to, go ahead. But like, I remember a teacher was telling me there was a year that the formula sheet, it was wrong. Like one of the things were wrong, and students used it. So whoever used it, they got the question wrong. And so I mean, if you want to, go ahead, but just remember that there was a year when there was a typo, so the formula was wrong, and anybody who used it got the wrong answer. So,
Okay, thank you.
yeah, I really don't recommend using it unless you absolutely cannot remember, then you flip back to check. But please don't rely on that too much. That's why I've never even mentioned it ever to you. I was trying to do that maybe coming down to the end or something. But like, yeah, I don't recommend.
LOL.
Yeah, I wasn't. Yeah, I really don't want you to use it unless it's absolutely necessary. Like you had an anxiety attack on the day of the exam and you can't remember anything, and that's not gonna happen, right? That's not gonna. That's not gonna. Yeah, like I said, I'll find the area. I'll find the curve view, the equation of the curve. Can you try number 5 for me? Yeah, number 5, number 6, and that should take us to the end of the class. So this one was a bit different because they did not give you the equation of the curve. They gave you a point, 2 points that lie on the curve. They said the coordinates of P, I think it was 0. Was it coordinates of P? I think it was 0, 8. And then Q was 4, 0. Right. Anyways. Those were the coordinates, right? Yes, no.
Yes, miss, those are the coordinates.
Okay. So they gave you 2 points that lie on the curve. Q and P. They said the coordinates of P is 0, 8, Q 4, 0. And they also gave you the gradient function dy and dx. And they said that this is equal to 2 minus 2x. So they give you 2 points. They give you the gradient function. And then they ask you to find the area. That's kind of sus. Why? Because they did not give you the equation of the curve. What I taught you, the formula requires that you know the equation of the curve. That would be your f of x. Just in case you need to see what I'm talking about. Remember area. Remember area is equal to f of x dx, where your upper limit is b, lower limit is a. F of x is always the equation of the curve. They did not give you the equation of the curve. So how are you supposed to find the area of the region? Well, they require you to find the area of the curve. How are you going to do that? Indefinite integration. That's one of the, no, that was what we did when we do an application of indefinite
And
integration.
substitute the code.
Huh?
And then substitute the coordinates in it, but it have 2 sets of coordinates here rather than just one coordinate we had before.
Yeah, but it doesn't matter because both of them lie on the curve. Just like when you were doing coordinate geometry, if you had 2 lines lying on the line and you're required to find the c, so if you had y is equal to mx plus c, and they gave you 2 points on the line, say it was 0, 5, and like 2, 3. Let's say you knew that the gradient m was equal to 6. To find the value of c, what you did, you either substituted this point, so where x is 0 and then y is 5, or you could have used this point where x would have been equal to 2 and y is equal to 3. You would get the same value for the constant c. Same thing here. It does not matter which point you substitute into the equation because both points lie on the curve. So yeah. This is why it's important for you to know what you're doing, because here is a question about definite integration and finding the area, but you needed to use your knowledge of indefinite integration in order to find the area of the curve. That's why it's important for you not only to know what to do, So like, sure, you might know how to find the area of a curve, but it's also important for you to know when to do it. Here is one of those scenarios. You need to know that I have to use indefinite integration first to find the equation of my curve, and then I can apply my rules of definite integration to find the area of the region, right? So, knowing that, when we are doing application of indefinite integration, to find the area of the curve, we had to integrate the gradient function. Same thing we're doing. We need to integrate this, 2 minus 2x. That is the only way we're going to get the equation of the curve. So integrating the 2 minus 2x with respect to x dx, I am going to get 2x to the 1 on 1 minus 2x squared on 2. This is indefinite integration. Don't forget your plus c. I can simplify this even more to give me the 2x minus these 2's would cancel, x squared plus c. This is what I'm working with. But there's a problem. When we're doing application of indefinite integration, we said this is not the exact value of the curve. We need to find the value of c. And how did we do that? Well, in the questions that we did before, there was only one point, and then you took the point and you substituted it into this right here. So this is y, right? Y is equal to the integral. So y is equal to 2x minus x squared plus c. What we did before, we were given only one point on the curve. Then we took that point and we substituted it into here to get the value of c. Now we have 2 points lying on the curve, but that's not a problem. Since they both lie on the curve, it doesn't matter which one I use. I can decide to use point P or point Q. I will get the same answer for my value of C. So using point P, just because it's the first one there. Remember the coordinates is in the form xy. So when y is equal to 8, x is equal to 0. So x is 0 minus 0 squared plus c, and therefore my value of c is going to be equal to 8. So the equation that I'm looking for, well, the equation that I want, the equation of the curve, is now y is equal to, just rearranging this a bit, minus x squared plus 2x, and then my c is 8, and that's plus 8. This is the equation of the curve that I will be working with now. And I can use this to put it into my formula right here to find the area. Everybody good so far?
Yes, miss.
Okay, just one more person answer me. You good? One more person answer me. Yes? No? There's something you're confused about? Let me know. Let me know. Okay, I'm erasing. Like I said, if you use this point, you will get the same answer, right? Let me just do it for you. These sessions take a lot of you. It takes a lot of me. Oh. This is nothing, a 2-hour session. That's real short. This isn't really anything, to be honest. I don't really have time for